on Schoology. I actually opened up, I think, 3, 4, 5, and 3, 4, and 5 are due also this Friday. I extended the date because a couple of you had been out of town, so those are open for you. So please let me know if you can't get into them if you need to. Okay. So that's what we have available. Number 1. So we're looking at, will the parabola open up or down? Use x equals negative b over 2a to find the coordinates of the vertex. We know that finds just the x part. And then we plug that into what to get the y part? Good. And the axis of symmetry is always what part of x? Okay. And complete the table of values and sketch your graph. So y equals x squared plus 4x. Reese, what's A?
A is 1.
Good. Reese, what is B?
Is 4.
Reese, what is C?
0.
Yes. Okay, good job. So sometimes we might have our B value being 0. If the A value is 0, it just becomes a straight line. It's not a parabola. All right, so, Ray, so open up or down? Up. Why? Yeah, A is positive. Like it? All right. Celine. I want to find the vertex, so I'm going to use negative b is what? Negative 4 over 2a. A is 1. Negative 4 divided by 2, which is? I like it. Did everyone follow on what we just did? Celine, what am I going to do to find the y component of our vertex? There you go. So I'm going to plug this in, this negative 2, I'm going to plug in here and here. Now here's a question, everybody. If I squared negative 2, what is the answer? Is it 4 or negative 4? It's 4. I'm squaring a negative. I'm going a negative times a negative, and a negative times a negative is a positive, so I get 4. So this gives me a 4 for an answer, and then minus 8. 4 minus 8 is how much? Shout out. Negative 4. So I know what my vertex is equal to. Agree? All right. Cool. Ashley. Axis of symmetry. Say it though as an equation. A negative
2, negative 4.
No.
Or x equals negative 2.
There you go. X equals negative 2. And that's going to be a vertical line that has an undefined slope, and it goes right through. Does the axis of symmetry, is that actually part of the graph, or is it just used? Okay, cool. I think we're kind of ready to start graphing some stuff. And we can also do the table. So let's graph down here. Negative 2, negative 4. There's my vertex. I guess I could draw in my... Get taken care of. I could draw in my axis of symmetry. That's the line I'm going to fold over. George, does this parabola open up or down? We already answered that, but tell me. Opens up. If the parabola opens up, do you feel, George, that this would cross the x-axis twice or not at all? Yes. Yeah. Okay. So it will cross the x-axis. Now, trick question. Do we always know exactly where it crosses the x-axis? No. If we do, what can we do with the problem? Factor. Good. if we can't factor the problem, it's not going to be exactly known exactly where it crosses. Thank you. If we don't know exactly where it crosses, what kind of number did we call that? Who said that? Yeah, maybe. Irrational. Good job. Yeah. All right. So, have we answered it? We said, let's see. Well, the problem open up or down, we got that. Use x equals negative b over 2a to find the coordinate of the vertex. We got that. Got axis of symmetry. Find any roots. What does that mean when I'm looking for the roots now? Huh? GCF could go with this, absolutely. So GCF, greatest common factor, so you're starting to what the problem? I just said it a little bit. Factor it. Okay, this one does indeed have a greatest common factor. What's the greatest common factor on this, TJ? 4. Nope.
Oh, it's x.
X. So if I factor an x out, I get this. Okay? And I can set this equal to 0. So what? You're going to nail it. You're going to say it. Yep. Andrew. X equals 0, x equals negative 4. What does that tell me? On the graph.
Where the 2 points are.
Okay? Which axis? X-axis. Excellent. So we know it crosses at 0, which is right here, and at negative 4. So that's negative 1, negative 2, negative 3, negative 4. That's okay. So then they ask us to use this t-table to figure out the rest. Okay, so I'm going to do like this. I have x, y. What should I put here in the middle? What should I go here? Okay, because that's the vertex, right? So 0, negative 4. Oh, no. Negative 2, negative 4, sorry. Do I know 2 more points without even factoring this? Yeah. So I know, what's this point right here, Mac? 0. And? 0. Good. Mac, what's this point here as a point? -4. Comma? 0. There you go. So I didn't even have to do work. I already knew roots. I knew some roots, so those are 2 points. So let's do this. What is a number, Gage, what's a number to the right of negative 2? One number to the right of it.
1.
Real close.
0.
Just one to the right.
Oh, just 1? Okay, negative 1.
Negative 1, and what's the number this way?
Negative 3.
There you go. So I need to, negative 1, negative 3 should yield us the exact same y component.
Yes.
Okay, because it's symmetric. So I'll have to pick one of those numbers and plug it in. Gage, which one of those numbers would you like me to plug in to my original?
1.
Negative 1. So let's plug that in. So let's be cautious. I have negative 1 and we're squaring it, plus 4 times negative 1. Gage, if I take negative 1 and I square negative 1, what do I get? 1. Yeah, we lose the negative. And then 4 times negative 1 is negative 4. So 1 minus 4 is? Negative 3. And this should also be negative 3. Okay, so I have negative 1, negative 3. Guys and girls, this is my boss. His name's Mr. Moore.
Hi guys, how is everyone? Don't you just love math? I'm an administrator now, but I was a math teacher, so this brings joy to my heart.
He taught at Eagle Crest, Thunder Ridge Middle School, Grandview, anywhere else in the district?
That's it.
That's it. He's also the president and chief of Career Tech Ed. So that little building over there that I always tell you to come over to, that's something you can't find. So, yeah. Did I answer everything about this question? Yes, ma'am.
So, question on the chart. So, when we go to the left, we go down, and when we go to the right, we go up on like the top part of the chart.
So this is how I think I'm going to answer your question correctly. So from our x component of our vertex, I'll go one to the right and another one to the right. So if I go one right, I get to -1. If I go another one right, I get to 0. If I go to the left, I get to -3, then -4. If this was like 12, I'd go 13, 14. If this was 12, I'd go 11, 10.
Okay, so is it always like that?
For right now, yes.
Okay.
It's a good way. We are actually going to start seeing tomorrow something called a pattern graph that comes along with these. And then you guys are getting mad at me going, why didn't you show us in the first place? Sorry. But it's just another way of looking at it, and works really well with parabolas. Yeah?
Why do we find the roots?
Why do we find the roots?
Yeah.
Because that would just be 2 more points to identify. If it doesn't factor, they're irrational, so we can't necessarily find them. Thank you. We'll find about where they're at, and so sometimes that'll happen, sometimes it won't. Say that one more time. You could, yes. And that's technically what we did with this problem. But they don't always all the way factor, right? Okay, so that's this problem. But I want to walk in and start on what today's notes are. I think we can finish the rest of that. I'll do a little bit more of that tomorrow. But I want to get you what our notes will be for today. And it's a front and a back. And this actually does go along quite a bit with our Schoology assignment. So remember that's due when? Friday. So guys, girls, I actually figured this out the other day. I'm going to continue to give you guys 1 to 2 of these small quizzes on Schoology throughout the rest of the year. By you doing that is going to be equivalent to probably 3 in-class quizzes. Meaning you can do it multiple times and get it correct. You could really do well. If we get enough. Casey, did you get one of these?
Yeah, we just had extra.
You had an extra?
Nope, just one.
The bread is all All right, I did number this at the top. I used a fancy pen in order to make that number. It looks like this, but yours is in orange because I only copied it in black and white. So let's talk about these. Let's see if we can do this. Let's see if we can lead ourselves through. So I'm going to be, this is the top of page 1 notes, and this is going to be our quadratic that we're going to use. We okay? And notice, there is a whole bunch of questions that come. Now, guys and girls, I'm going to tell you that a part of just any things you do in life, there's going to be multiple answers or multiple scenarios that work for it. Do you agree? You know, that could be any facet of just saying, hey, let's go to lunch. There could be multiple thought processes take place to making a decision. And we know there's tough decisions out there. We want everything to be a good decision, a happy decision. There's some tough decisions. So this kind of, us allowing us to fill out all of the parts of the scenario are going to help you. And I think on that Schoology, is it the Schoology 7 quiz that says list all that's true about this problem?
Yeah.
Okay. There's a lot of thought that goes into that. That's not just a multiple choice problem. Okay, if there's multiple choice, you have one answer that's going to work. But now there could be 6, 7, 8 different things that go towards it. That's a little different thought process than just trying to use logical thinking to say, okay, I could probably eliminate down to 2 choices, and I'm going to use an educated guess to get my right answer. Now I have multiple answers that are given, and that's a nice higher thought process question. Okay? So, Mac, coming to you on this one. Mac, can you help me out with this problem? Can you tell me what my A, B, and C are? Mac, would you feel by looking at this problem you could tell me that it opens up or down? And if so, why?
Up because A is positive.
Love it. It opens up because A is positive. Okay? It's awesome. Do you think that's some logical thinking right there? You have a few cues to the problem. You look at the problem, things that kind of could pop into your head. Okay, I know I have an A, B, and C value. Oh, wait, this looks a little weird. Maybe the B value is not there. Maybe the C value is not there. That means that 0 falls into B or C. Okay, we can decipher if this parabola opens up or down. So there's a lot of information that just labeling A, B, and C can do for us. Okay? So we're coming down the page. We're going to eventually graph this parabola. Is it open up or down? How do you know? Well, we've answered that. So that first question at the very top is answered, and the quadratic is right there, so we put that on that page. So we need to find the vertex, and the vertex is a high point or a low point. So if this parabola opens up, Kenzie, it opens up. With me? Yeah. Is the vertex the highest point or the lowest point on this parabola?
The lowest point.
Lowest point. And I said that the vertex is where it changes direction. So we talked a little bit yesterday that there's a point where your graph is decreasing and it gets to the vertex and then it starts doing what? Increasing. Okay. All right, so let's find our vertex. And we're going to use negative b over 2a. And then we'll plug that back in. TJ,
Yes.
negative b over 2a. Help me out.
That'd be -2
So that negative comes along and we'll get what?
over.
Over?
It's -2 over 2.
Negative 2 over 2. Okay. What happens with this negative negative? You get a positive value. Everyone agree? So I get a positive value because of that. And what's 2 over 2?
1.
1. And in order for me to find my vertex, TJ, what do I need to do? Where am I going to plug it back in? I'm plugging in for the x's. So here and here, I'm going to plug 1 in. So let's see. I bet you we can walk through this. 1 squared, speak out. 1 minus 2 times 1.
2.
Negative 2, then minus 8. So I have 1 minus 2 minus 8. 1 minus 2 is what? Negative 1. Negative 1 minus 8 is what? Negative 9. I have my vertex. And we said this vertex is the lowest point. Right? Oh, hang on. I have a vertex, yes?
Yes.
What is the min slash max? We said it's the lowest point, so are we looking for a minimum or a maximum? Minimum. What is the minimum value up here? What? Say it. Say it. Just negative 9. The minimum is just negative 9. Yeah, baby. See what happens, you get the right answer, you get slugged in the chest. Negative 9's our minimum. So our minimum value is, if I can spell, is negative 9. I look at the y component of the vertex to get the smallest value. This parabola is open upward. I have a minimum value of negative 9. That means we're looking at the y component. The y component is known as the range. It is known as the output. It's opening up. What's the maximum? Where's it going to in the y direction? Infinity. Okay. We have a minimum right there. All right, let's see. Oh, wait a minute. Hang on. I think I can do this. What if I drew this and I have 1 negative 9 Is that okay? Let's put a bigger dot so it fits in that right region. Okay, it's opening up. So as I'm traveling this way in the x direction, where am I coming from? Graph, sir, where am I coming from? Where? Negative infinity. And I'm doing what up to the point 1? Because this graph is doing this, correct? Making a big U?
Yep.
Okay? So I am coming from negative infinity. So this graph was way up here. What's it doing?
Decreasing.
Decreasing. So tell me where this is decreasing using our x values. Negative infinity to what?
1.
Good. Negative infinity to negative 1. Should it be, I include the point 1 or not? This is way high math. I want you to think about this. The vertex is also could be called a turning point.
Wait.
The vertex could be a turning point. So I'm going from decreasing to increasing at the vertex. Still with me?
Yep.
Make sense, Reese? So, do I include the 1? Or do I go up to the 1? Think about it. If you're on a roller coaster and you're coming down a hill, and I realize the roller coaster is not a parabola, but just go along with me on the story. If this roller coaster is coming down, and you are decreasing the altitude for the most part, so basically you're getting faster and faster and faster. As soon as you get to the vertex, you're going to start going up the hill. So do the forces on your body feel different when you're going downhill versus going right uphill on a roller coaster?
Yes.
Yeah. Is there a moment in time where it's kind of like, oh, there's nothing here?
Yeah.
It doesn't include.
So it doesn't include. Doesn't include. Very briefly, I agree. But there is a moment in time. If you're able to take snapshots and you have forces on your body, if you're coming down at that instant, you're at the very bottom, and you start to go back up, your body goes from the wee to whoa, right? You with me? You guys all been on that roller coaster?
I've
Yeah.
never been on a roller coaster.
Okay, that's your homework for the
What
summer.
about eulogies?
You got to go on one. Tristan, you go on a roller coaster this summer. That's your homework, and you have to tell me about that. Okay. Then we're gonna have you ride. We're gonna have you ride a bicycle or roller skates down a big hill until it flattens out. You tell me how you feel.
We're going to throw you out of an airplane.
Speak up.
Yeah.
You guys want to hear a funny story about a roller coaster?
Really big guys. It's so scary.
So, Mr. Moore might remember this roller coaster. You remember the zipper? So they put you in this L-shaped contraption. It's you and 3 of your friends. And this thing kind of did one of these. Well, I remember we got in one that started spinning like crazy. And it was like going around and around. And so your cart you're in flips you upside down. And then it also goes around this track that's kind of this big cylinder-looking thing. So you're going way up in the air. So our thing is spinning like crazy. And, the guys on there are like, yeah, this is fun. All of a sudden, I'm like, I don't feel good. And so, you're talking to the ground, talking to the sky, talking to the ground, talking to the sky. And, trying to tell the guy who's operating, I don't feel good. And he's like, he's got one tooth. Because most guys that work at carnivals like that. Sorry if your parents do. My dad has tooth. So, I'm trying to communicate. Now, all the guys that are in this contraption with me, we're like locked in place. And they're trying to squeeze away from me and go, Sturp, that feels good. So they're fighting the forces of gravity and other forces that act upon our bodies.
That never
So
works.
we get to the top of this thing, and it is spinning. And all of a sudden, it's like,
Did you
And I'm
catch
telling-
it in your mouth?
no, well, no, I got it all out, fortunately.
Thought you would have
Pretty-
caught it.
Now, here's the silly thing about it. So, I lost lunch like there was no other. Okay? We get off the ride. I have nothing of vomit on me. The guys with me are covered. It's like, how did you come out clean? The other guy's like, oh, man. It's always a good story. You gotta love it. So
the moral of the story is don't ride it with Mr. Stirrup.
Good to know.
got a wimpy tummy. Yeah.
I had that sort of thing happen one time. I was on like a road trip with my family, and one of my friends was just like, "Oh, I really need to go back to and so he peed in a cup, and then he was like, "I don't know where to put this now," so he threw it out the front window, and the back window was open, and it just came flying around and hit my other friend.
Was there mouth?
There's great things with road trips. Always come with a great story. You gotta love them. All right, let's finish up this problem. I'm sorry, I got us off task, believe it or not. All right, we got plenty of time. All right. Hey, we answered where it's decreasing. Where is it increasing?
No, negative 8.
Oh, wait. I made an error. I made an error on decreasing. There's an error on decreasing.
It's infinity to negative 1.
Where do you get negative 1 from? I put negative 1 too.
Oh, it's
Good thing we had that little pause in the middle. We were able to catch the error. Why is it 1 and not negative 1? Because our x component of our vertex is, Reese? Positive 1. Reese is praying again. All right, where am I increasing? From where to where?
9 to 1 to infinity. And 1 to infinity.
Remember, increase, decrease goes with the x component.
1 to infinity.
1 to infinity. And it's rounded as well. So 1 to infinity, it's increasing. So this graph is doing this. This graph is doing this. Yes? All right. How would you write this in functional notation? We're there. This is the notation we're looking for. Okay? We're using negative infinity. We're using positive infinity. We're using a parenthesis to say we're going up to that point, but we're not including it. If it was a square bracket, we would include that point. Okay. I think we're doing all right. Increasing, decreasing, we're doing well. Let me move on board. Okay, we are now going to be asked to do our table. We have x, we have y. What is this point right here going to be? 1, negative 9. It's the vertex. It's right in the middle. Okay? So I'm going to go a number to the right of 1. What's the number to the right of 1?
0.
2.
To the right of 1.
2.
2. And then to the right of that?
3.
To the left of 1?
0.
To the left of that? Okay. Which values go with each other? We'll have the same y component.
0,
0, 2, and? Negative 1 and 3. They will have the same. We're going symmetric about the origin. So we know that, did we ever write our axis of symmetry? We never did. Our axis of symmetry is what? X equals 1. Good. Okay, so this is our axis of symmetry. It could be a dotted line. You can make it solid. It doesn't matter. You can use a crayon on it if you like. Highlighter or something. Doesn't really exist as part of the graph. All right, let's finish this problem. All right, I'm going to take 0. I think 0 is easier to plug in than 2. Do you agree?
Yes.
0 squared. 0 minus 2 times 0. 0. 0 minus 0. 0 minus 8. If that's negative 8, what else is negative 8? Okay? See you, Tracy. What's easier to plug in, negative 1 or 3? They'll give us the same answer. Negative 1, okay? Negative 1 squared. Negative 1 squared is 1, good. Negative 2 times negative 1. Positive 2. 1 plus 2. 3. 3 minus 8. This is negative 5. This is also. All right, let's plot it. All right, so I get 0, -8, which is here, and 2, -8. And then I get -1, -5, 1, 2, 3, 4, and 5. And 2 and 5, -5. Okay. Uh-oh. Wait, what?
It's 3 and 5.
3 negative.
1, 2, 3, -5.
Okay.
-1, -5. 2, -8. 0. Maybe I said it wrong. Do I have it right?
Yes.
I think it's
You
right.
just said it wrong.
I said it wrong?
Just
Okay.
negative.
Hey, this appears that it's going to cross the x-axis twice. Agree?
Yes.
Let's see. I wonder if we could factor this. Can I factor this? X squared minus 2x minus 8. What's my magic number? -8. So the factors of -8, one's positive, one's negative. I have 1 and 8 and 2 and 4. What combination of that would work to give me -2 for an answer? What? -4. So -4 and +2 is going to work. So I'm going to do x squared minus 4x minus 2x minus 8. What do I have in common here? X. So that leaves me x minus 4. This is negative, so what do we know? Negative what? 2. Changes both of those signs, so that gets x
Minus 4. Plus 4. Minus 4. Minus 4.
Plus?
Minus 4. Minus 4.
Oh, you know what I did? That's supposed to be a plus. Ah! That's supposed to be a plus. That's supposed to be minus. Boy, I can't factor today. X minus 4 and x plus 2. Where's my roots? Where's my roots? 4. And what? -2. Those are my roots. Look at all these points I have on this parabola. Happy day. Happy day. Okay, so it could factor. These are rational roots. The reason they're rational roots is they cross the x-axis at a place that we know exactly where they cross. Okay, if this didn't factor, they would have been irrational because we would have gotten some strange answer. Oh, wait a minute. Okay. Okay, domain. This is new. We've talked domain and range before, I think. No, you haven't. Yes, I have. It was like back in October.
Oh,
So
yeah.
you should remember back to before Candy Day. Okay, domain is the x values. Okay? So, I want you to think about this. I'm going to start over here by Mr. Moore. We are at -infinity in the x direction. We're talking about the domain. Does my graph exist way over here? Way up top?
Yes.
Yeah.
Yeah. If I was walking this way, have I stopped with the graph at all?
No.
The graph keeps going. It changes directions, right?
Yeah.
It keeps going. So is there any x values that you think might not work with this problem? Like if I were to go from -100 all the way to +100, which I realize is not negative to positive infinity, but if I were to take -100 and plug it into my answer, Reese, would I have gotten a y value out? -100 squared is a big number. So would I have gotten a number out? What about +100? Do I get a number out? Anyone want to take a shot at what the domain of this problem is? Where did I start? Where did I end?
Sorry.
I started at -infinity, and where did I go to? So from -infinity to +infinity. My domain, forever to negatives, to forever to the positives, my parabola will result in some sort of answer. It's a continuous function. It keeps going. It grows really quickly off of our graph. -10 to +10 doesn't mean that the graph exists only there. It keeps going in either direction. Okay? This parabola, as I go to -infinity in the y direction, goes to +infinity. If I go to +infinity in the x direction, I also go to +infinity. So my domain is from -infinity to +infinity. We exclude everything. Now, range. I think I can squeeze this in here. Extend page. Cool. My range. Where does my graph go all the way up to? Positive infinity. Both of the arms will extend up to positive infinity in the y direction. Do you agree?
Yes.
Still with me? Where did I start my ride up in the y direction? Where?
-9.
-9. So from -9 all the way up to infinity was my range. Okay? Is there a point at that -9? Mac, what do you think? Is there a point at -9? It starts with a V. It's called the vertex. So is there a point there? What do you think? Is the vertex a point?
Yeah.
Yeah, it's right there.
Okay.
Okay, so do I include -9? Yes. So what do I need to change on my range? One of the brackets.
You make a square.
Where?
Uh,
There you go. This is a square bracket. This means we include -9 as part of our range, and we go all the way up to infinity. Yo.
I'm sorry, can I please use the
Yep.
Thank you.
You don't ever have to ask. You can always go.
Just feels so awful.
There's a lot of information on this problem, Greg. So this is what I want to do for tonight's assignment. Flip the page over. See a big number 2 at the top?
Yep.
Perhaps you started with the number 1 at your top.
It looks like a Z.
So if you filled out the number 1 side, we're going to do the number 2 side. If you filled out the number 2 side, which is identical to the number 1 side, then do the number 1 side. I want to give you one problem. One problem. It's going to walk exactly along with this problem. It's going to be a little bit different. But I want you to use y equals -x squared plus 9. Now, I'm giving you 11 minutes. I want this done in 11 minutes. I want you to work with each other. You can jump on any of the boards, work with it. We'll go through it as a class together. Myself and Mr. Moore are not available. Work it out. Figure it out. We're going to have that as homework, and then I want you to complete last night's homework. Okay? Because a lot of you didn't get all the way done. Right? And I think you have enough information to go all the way through last night's homework and get it completed. And I will check it off tomorrow. But then I want this problem done by the end of the period. Got it? So this will be on the back side of that page. Go for it.